In this video, I'm going to be showing you how to find the length of a chord. And what a chord is a line that goes from one edge of this circle to the other edge of the circle. I guess the obvious chord would be one that goes straight through the middle. That is a diameter. This would be going from one spot on the circle to another. How can we find that? Well, you're going to be given that the radius is 6. So you're going to need to know the radius. And what would make this really easy is, so from here to here is 6. From the center to this side is 6. Is if we were given this, then that would be very easy. We could use the Pythagorean theorem to solve for this side and this side. But we are going to be given this angle instead. So let's say that this angle is 120 degrees, the interior angle, meaning that from here to here is also 120 degrees, that this represents 1/3 of the circle. All right, so how can we find the chord AB? Well, let me take this triangle out of here. So we know that this is 120, this is 6, and this is 6. And we're looking for this side. Well, if I were to turn this into two right triangles by adding a perpendicular, that would bisect this angle, making it a 30, 60, 90 triangle. And if you're given an angle and a side on a 30, 60, 90 triangle, you can find all of the other sides. So here we have that the sine of 60 is going to be, so we're going to solve for this x and then double it to find the other x, would be the opposite over the hypotenuse. So equals x over 6, where 6 is also the radius. 6 is, it's the hypotenuse, but it's also the radius. So you could say sine of 60 equals x over the radius. And sine of 60, the way that we got 60 was we bisected that angle. So it's really sine of whatever angle you have divided by 2 equals x over r. So we're going to multiply both sides by 6. These will cancel. So you have 6 sine of 60 equals x. All right, so that gives us one of the x's. We need the other x. So we're going to multiply to get 2x, multiply by 2, which gives us 2 times 6 times the sine of 60 equals 2x. And 2x is the chord. So if we solve 2 times 6 times the sine of 60, we will know the length of that chord. So this is 12, and the sine of 60 is square root of 3 over 2. And that equals, I'll change it to AB now, equals the length of the chord. And then simplify here, 6 square root 3 is the length of the chord. So what we really did was we doubled the both sides. Once we had, you take the r times sine of half of the angle equals x, but since we wanted 2x, you double it, and 2x equals the chord. So the formula to find a chord is 2 times the radius times the sine of half of the interior angle. Or you could replace this with diameter. You could say it's the diameter times the sine of half of the angle is the chord. So if it were 100 for the interior, it would be, with a diameter of 12, it would be 12 times the sine of half of 100, 50. If it were 100 for the interior angle. If it were 90, it would be 45 for this number. All right, so here's the question. What is the length of a chord that goes from the 10 to the 2 on a clock? So from here to here. And that the diameter is 12 inches. So from here to here, we'll say is 12, so 6 and 6, which makes this 6 and 6. Okay, so from the 10 to the 2, that consists of 4 numbers out of 12. So this is 1/3 of the clock. So it's either 1/3 of 2 pi, 2/3 pi, if you want to leave it in radians, or you could convert it into degrees and say this is 120 degrees. 1/3 of 360 is 120. So similar to this question. Actually, it's going to be the same question, but let's plug in just these numbers given the formula. So we know that it's 2 times the radius times the sine of half of the angle equals the chord, or the diameter. So the diameter is 12 times the sine of half of 120. So it's 120 over 2, which was the sine of 60. Sine of 60 is square root of 3 over 2, and 12 times the square root of 3 over 2 gives you 6 square root 3 equals AB. Same question, just a different context there. All right, so that is how you can find the length of a chord. Even if you do not memorize this formula, you could get to it.